Hello everyone, welcome to Screencast SC10161. Today we'll be looking at the advanced troubleshooting packet capture features of the Wing 5 platform. We'll have an overview of the various capture points on a Wing 5 device. We'll be looking at using the packet cap command, using the remote debug live packet cap command. Later on we'll discuss a caveat with using the Tasman sniffer protocol. So here we have a representation of a Wing 5 AP. We can see the various physical and logical interfaces. The Wing 5 allows us to capture in multiple directions of any physical interface, like your GigE1 interface or your radio interface, and logical interfaces such as VLAN or VPN. It also allows us to capture actions such as drop actions of any packets that have been dropped, or denies, which are based on ACL deny actions. The topology I'm using today is real simple. I've got an RFS 4010 with a 7131 adopted at layer 2. Got a laptop running TFTP, and it will serve as my TZSP host using Wireshark. Then I have a wireless client, which is my smartphone. We're going to start with localized capture, looking specifically at the packet cap command. You want to use this command on the specific device where your desired capture traffic will either be destined to or will be traversing. An example is the association traffic of an MU to a specific AP. The 4 commands shown are the commands we'll be looking at first. Here I'm connected to my RFS switch, and since we want to use the packet cap command on our target device, I want to connect to my AP7131 that's adopted to this switch. So simple to connect here. I've only got one AP. We're going to use the connect command. Log into the AP. Now we're connected. So we'll start off with a simple capture on radio 1. Service packet cap on radio 1. Now by default, with no other options, the command will capture 50 packets and then stop automatically. This is so as not to overwhelm the AP or to interfere with clients who are currently connected to the AP. We can see here that I've got some beacons, a lot of probe requests. Those are from my phone, some probe responses. So let's say we want to filter out those probes and just see our beacons. We can do this utilizing a filter, using the same command, and then filter not .11 probes. Now the filter command, when you use this option, the last option that's allowed in this command. So any other options you're going to use, you need to put before the filter. So we're going to run this again and just get our beacons. Now we can see that there are no probe requests or probe responses. Now suppose we want to verify that a client is making a DHCP request and getting a DHCP address. We don't want to capture the 802.11 wireless traffic, so we're going to capture at the wireless interface of the AP. This is the bridge from the wireless to the wired network. So we'll do a service packet cap on wireless. And then we can see, we do see some UDP in there, but we see a lot of other stuff, and this is basically noise for our purposes. So we want to filter this stuff out. So we're going to filter UDP. Now we're only capturing UDP traffic, and we can see the start of a DHCP request at the top. We can see here that my client has received IP address 192.168.150.49. And we've got some other information in there, but we've confirmed that the client is getting a DHCP address, and we can verify this by pinging the client. Now suppose we want to analyze our traffic utilizing an application like Wireshark or OmniPeak. We want to send this file to a TFTP or an FTP server in that case. So we're going to run this command again. Remove our filter option, and we'll add write TFTP : / IP address of our TFTP server, and we'll give it some random file name. I'll call it .tftp.pcap, and I give it the .pcap extension so that I can automatically open it with Wireshark when I double click on it. And we're going to add a count this time for saving time of 10, and we'll filter UDP again. When you specify a location other than the console, it will give you a count of your packets captured rather than displaying the packets on the console. So there we can see we've captured the 10 packets I specified. If we go look in Explorer, we can see the file there. If we open this with Wireshark, we can see our DHCP and some other traffic, UDP traffic. Now, a couple more options with the packet cap command is to capture actions like deny and drop. These are based on actions taken by access list rules or firewall rules. Using the deny option, we will capture packets that have been denied as the result of an access list. And using the drop option, we'll capture packets, any packets that have been dropped for any reason. It doesn't have to be specific to an ACL. So let's display this now. We'll start with the drop option. Now I've written an ACL and applied it to VLAN 1 interface of this AP. And it's a simple ACL that denies ICMP traffic and allows all other traffic. So we're going to capture that, and then we're going to send a ping to our host. We can see the pings are timing out. So we've gotten a number of drop packets here, some UDP stuff, but specifically here's our ICMP traffic. And remember, the drop option is going to show you any packet that was dropped for any reason. So that's why we've got the UDP as well as the ICMP, some beacon traffic in here. We can see that my ICMP packets were dropped as the result of an ACL match, and it gives us the deny rule number. It shows us the source, the destination, and what kind of packet it was that was dropped. So now we'll look at the deny option. We'll go back and do our ping again. Our pings are timing out, and we can see that they're being displayed on the console. With the deny option, it's actually showing us the name of the ACL that caused the action. And then it gives us the relevant information, source and destination again, and the packet type, an ICMP echo request. So these are two good options for verifying if your ACL or firewall rules are working, or for just seeing what kind of packets are being dropped at a device. Now we'll take a look at using a Wing 5 device as a sort of distributed sniffer. New in Wing 5 is the remote debug command. This command allows us to connect to a remote device in order to obtain logs, crash files, traces, and other information. We'll specifically look at the live packet cap option of remote debug, which lets us perform packet capture on our remote devices. When this command is executed at multiple devices, the resulting captures will automatically be collated into a single stream on our parent device. Typically, you would run this command at a controller. We can see here that we have two options, host and RF domain. Using host, we can input multiple devices to capture from, separating them with spaces. Using the RF domain option, our parent device will capture from every known device in the RF domain, APs and controllers alike. As we only have a single remote device, our command will be simple. We'll use remote debug live packet cap host APE 7131. We'll write to a TZSP host, which is my laptop running Wireshark, and we'll capture on the wireless bridge interface of our remote device. I'd like to first discuss a caveat with using TZSP. TZSP is an encapsulation protocol that will wrap our data in UDP. By default, a Wing 5 device will send to port 37008. As we typically don't have anything listening on this port on our laptop, we will capture ICMP destination port unreachable messages along with the other traffic we're looking for. So we want to get rid of that garbage data. There's a couple ways we can do this. We can use a display filter in OmniPeak or Wireshark so that the messages are not displayed. We can also use a program called iperf.exe in server mode. This is freely available online as a Windows executable. Linux and Mac devices already have this command natively. At a command prompt, you will execute the command iperf.exe-s for server, -u for UDP, -p for your port number, and then input the port number 37008 as seen here. So let's take a look at the remote debug live packet cap option. So now I'm connected to my controller, and we're going to execute the remote debug command to capture from our remote device, the AP7131. So we're going to utilize the remote debug live packet cap host, specify this 7131. We're going to write to a TZSP host, which is my laptop. Input the IP address of the device that's running OmniPeak or Wireshark. I'm going to capture on the wireless interface of the remote device. So it starts the capture. If we go to Wireshark, I'll associate my device, and we'll see a bunch of traffic come across there. Now you'll notice I'm not receiving ICMP destination port unreachable messages, and that is because I'm running iperf in server mode on this device already. And you can see here that a connection has been formed between my laptop and the controller. So this option gives us the ability to do real-time packet analysis of many devices. In my case, we only did a single device, but if we were to input multiple devices, the RFS switch would automatically collate those multiple streams into a single stream, and we would get the entire capture here within Wireshark. You can see I've added a TZSP display filter in Wireshark so that I'm not getting any other Ethernet traffic that might be coming through I just want to see specifically that information that's being sent from the controller. I hope today's screencast has been helpful. For more information on the packet capture feature, there's a feature guide at the link shown. And if you'd like to download iPerf for Windows, you can download it at the link displayed. Thank you.